Hello everyone, my name is Ayush Savre. I am currently pursuing my BTech in GH Raisoni College of Engineering, Nagpur. I am a pre-final year student having majors in artificial intelligence. I had built a multi-agentic system where on the basis of the user query, it decides the which agents to call. Currently, we are having three agents as PDF RAG model, then academic research agent, then the web search capability agent. So first of all, discussing the technical approach here. For in backend, I had used a fast API. It has endpoints, clear endpoints as args, upload, and log. Then front end, I had used Streamlit UI to faster prototyping of the model. Then LLM, I had used Groq Cloud to access the API of the LLM. I am currently preferring to use a Llama 3.3 model here. And for vector database, storing the vector embeddings, I am using FAISS database here. The embedding model I am using here is a Hugging Face transformer model. And for PDF preprocessing, I am using PyMUPDF library to extract the text from the PDF and to process the PDF. Then for web search, I am using Serp API from Google. But it used for the purpose of web searching. For academic research paper providing, I am using arXiv API. So discussing the system architecture of my project. The front end consists of Streamlit UI. It has a basic clean UI having a search box and upload button, and in backend we have using a fast API with having args and upload endpoint. The It has a file controller, rule based. I am using a rule based approach. If a user hits the query to summarize the PDF, so it calls the PDF agent, drag agent. If the user provides a recent research paper on the certain topic, it called the arXiv agent. And if a user is searching about recent trends or recent news about the some certain topic, it will call the web search agent. So if the rule based approach fails to work, I am using a fallback towards the LLM model. It decides which AI agent to call. So discussing the project structure here, I am having a different folder as backend, frontend, and data storage. So in discussing first of all the backend part, I am having a main.py file. We are having a fast API roots as well as the application history. For API, I am having three endpoints: args API, args.py, upload, and logs. Args having a main query processing part where all the queries are being asked upon this endpoint. Upload, this is used when the PDF is being uploaded. Log stores the system logs. Okay, so the agent having controller.py, it is like a brain of our model, where it use rule based as well as and if rule based fails, it fallbacks towards the LLM approach. Then PDF row track have the RAG architecture of a PDF where user can directly interact with the PDF. Archive agent, it consists of archive API to search the recent research paper upon the certain topic. Web search API, it will help to search upon the web using the search API. Okay, utilities having all the utilities of the logging files or securities. So requirement.txt having all the required files on the uh, for the backend. .env.example is the sample for the environment variable. I am having a .env folder file here where where I'm storing the API key to securely store the API keys of the LLM as well as the API and search APIs. So front end contains the Streamlit part. Okay, so the data part have data folder having a uploads. The PDF being uploaded are stored here. The vector stores the vector embeddings. Now coming towards the front end part, the front end having a Streamlit app which has a Streamlit UI to basically display the UI for our model. The logs contain the JSON file. The sample PDF file contain the RAG testing files for the RAG model. Git ignore contain the files that should be ignored to while pushing towards the GitHub. Report having a detailed approach of our model. render what required file required for our deployment purpose while deploying on the render readme is the current this file. Okay, let's go towards the implementation part of the model. So I had deployed the model on the mm, on render. So the backend is currently live. It is working here. Its status okay. Multi-agent system API is running. Okay. The front-end part is being deployed over render, also in render. It is also currently live. Okay. So let's look upon the deployed part of our model. So this is the UI of our model. This is the UI of our model. It has a simple search box and upload folder. This is our system architecture, the front end part, back end part, the three agents and the LLM, preferring Groq LLM. Then vector store for vector storage, we are using FISS. So first of all, let's test the archive search model. If I search recent paper on image processing, let's say, and let's hit the args button. The controller pie will decide that as it contains research paper, it should call the arXiv search agent. So it had called the arXiv agent. Then the reason for calling is that as the user asks specifically about the papers or AR archive. Okay, it provides the overview of the papers, the key papers and contribution on the image processing topic, then research trends, then notable researchers, and recommended reading order. Okay, so this at last I am adding a JSON file which shows the which uh, which data is being extracted through the API. It contains a PDF URL, publish date, and the categories, and also the links to link of the paper. Okay, so now let's just take the web search API. If a user says recent trends on AI in 2025, so if I hit the args button, then query processing part, it should called search API model agent. So it is able to route towards the web search agent. So it as our rule-based approach failed here, so it used the LLM routing decision to call the web search agent. So the query is being searched over the web. Here it gives all the information about the recent trends of AI in 2025, then recent news conclusion, and this is the JSON of the data being extracted towards the API, the position where to rank the information, then the link towards and the snippet which is being displayed over the as a output. Okay, now just let's test the PDF RAG model. So let's say I am uploading a research paper here. uh, I am uploading a research paper. It first of all, how it work, it get uploaded successfully here. First of all, let's now discuss the behind the scenes what is happening toward in the PDF RAG agent. So here is the architecture diagram of the RAG model. Whenever the PDF is extracted, the PyMU PDF library extract the data from the PDF, and then it get stored using the Hugging Face embedding model. It get divided into chunks and stored into embeddings which is stored in the FISS database. So uh, now whenever the user sends the query to the model, and the embedding models divides that query into a chunks and embed into a vector database. Vector database and then vector database perform sends the query back to the orchestrator. Here, okay, the whole pipeline is handled. Whole orchestration pipeline is built using Langchain. So here, the LLM performs a similarity search between the embeddings, PDF embeddings, and the user query, and provides the output to the user. This is how our PDF model works. So if if I'm uploading the PDF, if I'm uploading the PDF here, let's first refresh the model. Now if I upload the PDF, if I upload the PDF here, it get uploaded. Each PDF gets its unique document ID. It get chunks into the PDF will get divided into the chunks. If I ask you provide the summary of the PDF and said ask, then it should call the PDF rag agent. So okay, so the agent was able to call the PDF rag agent. It follows the rule-based approach here. So it provides the summary over the uploaded PDF and the retrieved chunk ID, and the information provided in the chunks. This was the extracted text from the PDF. Okay, so this is how our model works. For the future enhancement we can do is we can use multiple rack agents here. We can also enhance the front end by using matrices upon the number of API calls. Also we can have multiple domain specific model towards it. Thank you so much.